Thank you very much, Jeremy. This is the occasion when I review some of the observations that have been submitted to BAA over the last 2 months, since I last saw you here, in fact, and look forward to what we'll be looking at in the next couple of months, and the state of the sky at the moment. But first of all, very important subject, I have to update you on the observatory cats, which I mentioned last time and attracted a certain amount of interest. This is the state that they were in back in September. That's my observatory. That's the shed housing my 14-inch telescope, and that's the shed housing my 11-inch telescope. And when I came back from the eclipse in America in August, I needed to do some work on the observatory because the rail that the roof of the main shed ran on had rotted, so I had to take these rails down. This is one of the rails. And I found during that process there was this family of cats living under this decking here. And that's the mother cat. And by the time I spoke to you in a couple of months ago, we've managed to give away this cat and this cat and this cat, but we still had we still had a couple of ginger cats, we still had this black one, and the mother was pregnant again. So, and I was expressing despair over what to do about them. But a very kind lady actually at the meeting spoke to me and said she had contacts in the cat protection world, and she actually managed to get some people to come over from Waltham Forest Cat Protection Society, and they managed to catch some of the cats. And they were very keen to get the pregnant mother, into care chute so she could have her babies. And she actually had 6 more babies, and they've gone to a centre in Surrey where they keep them and give them to deserving families. And they also managed to catch this ginger one and this other ginger one, but they didn't manage to catch this ginger one, who's always going in a different direction to this black and white one is always going in a different direction to all the others. And also, before that, another cat had turned up to eat the food that I'd left out for the kitchen. That was a big tomcat who may or may not be the father of all these other kittens, although he doesn't look particularly like them. And so the net result of all these developments is that then we were left with these two. That's the big tomcat who we call Big Tom, and that's Blackie. That's the sole remaining kitten that escaped the cat catchers, and we managed to get them neutered anyway, so there's no chance of any more cats. But as soon as they came back from the vets, he was on top of her again, trying to mate again, despite the fact that they'd already been neutered. And she went. This is my runoff shed housing 10-inch telescope, and she's hiding in that picture under that 10-inch telescope because she knows that he can't get on top of her when she's under there, because she can fit in the 3-inch gap under that shed, but he can't. So you may not have thought that an observatory could be used as a contraceptive. An anti-animal mating device, but you have seen that here today.
I think it played with a journal though.
Unfortunately, she's disappeared last Thursday out of the front door while I was getting my bike out and hasn't been seen since, so I hope she comes back. And Tom's been very sad since then. He's been somewhat off his food, so we're very, very much missing her. They look a bit bored there. I think perhaps they're waiting for something to happen on the sun. This is the image that I got off Space Weather yesterday, showing the state of the sun yesterday, and I've carefully credited it to Space Dynamics Observatory, this picture that shows absolutely nothing at all. So there's no sunspots on the sun at all. However, there have been some sunspots seen by our members since I last spoke to you. Here's an image from Dave Tyler. Dave is a very productive, very long-standing observer of the sun, hardly misses an occasion when sunspots are visible, images everything that's going on the sun, and that was taken in mid-February, and that was a major active group called AR2699, and he's also managed to image that in hydrogen alpha, and there it was, but now the sun's gone very blank since then. However, there have been solar-related features. It's reported on Space Weather that the sun is leaking solar wind, and we've been in this stream for a few days now. and the Earth's magnetic field is unsettled, and it's led to outbreaks of aurora, not to mention Steve. Steve is this feature here, and this is imaged by Darrell Pedersen from Alaska. Steve is actually believed to be, it was discovered very recently, only last year. It was observed by amateurs, and then it's been studied by one or two professional physicists. It's believed to be a high temperature, about 3,000 degrees centigrade, believe it or not, stream of gas in the upper atmosphere. It seems to be seen at the same time as aurora, but it is not an aurora, and it was originally named after something in some film where one of the characters gave the name Steve to something that they didn't understand, and now Steve stands for something in particular. It's been made into a backronym, it's called. In other words, it's been retrospectively given a meaning. It's something like something to do with emission and velocity, thermal emission, strong thermal emission velocity, something like that. So that's actually a backronym. So this is Steve, and that has been observed from the UK as well. It was observed from Scotland by some of our observers last year. And here's an aurora observed by Dennis Basinski in the north of Scotland just very recently, just in March the 23rd, that was. We've had another lovely sight in the evening sky. Over the last few weeks, we've had, as Richard McKim mentioned, Mercury and Venus visible at the same time. Venus very low in the twilight, and Mercury a substantial elongation. And this has been one of the best elongations, one of the most clearest I can remember. This is an image I took on the March the 13th. And here's another one from 6 days later by Nick James, when Mercury there and Venus, they're further apart at this stage, but they've been joined by the crescent moon there. Well, Mercury is now out of sight. It's gone too close to the sun, but the elongation of Venus is steadily increasing. And Mercury will be going into the dawn sky in April, and it will have a greatest western elongation, but it will be only 4 degrees high altitude at dawn, so you're unlikely to spot it. This is an image of Mercury. No, it's not. It's an image of Venus. Yes, an image of Venus by Chris Dole. So you really have to catch Venus before sunset at the moment, or in a completely daylight sky to get it as an adequate altitude. But no features there, but we can see the state of the phase. So Venus is going to remain very prominent throughout April and May. It remains about magnitude -4. Its diameter will increase slightly to 13 seconds, but still not huge. And its phase will reduce slightly, but it'll still be a large gibbous phase. Its elongation extends to 40 degrees by late May, so it will really be a prominent object in the sky after sunset. The moon, we're coming up to another full moon now, and the next full moon will be just late April, and so they're coinciding with the end of the month now. I think a lot of people will be going to dark sky observing occasions around this April new moon. This will be an excellent occasion to go to dark sky locations. I'm going to a dark sky location in Wales to try and see faint galaxies and so forth, because this is the time of year for galaxies, and it's the time of year when we can still get a decent amount of darkness. So that dark of the moon will be very useful to deep sky observers. Here's an image of the moon. I thought this image was going to be a bit of a failure when I took it. For some reason, I had some either software or hardware malfunction, and whereas normally the camera should take a few hundred frames a second, on this occasion it only managed a couple of frames a second, and only got about 100 frames there, but I processed them and they turned out not bad. And that's the southern Mare Imbrium, and that is Eratosthenes there. And this is the drowned crater, Stadius, famous ghost crater, where the lava has flooded over and obliterated the old walls. And I spotted on the BAA members section website, this is really remarkable. I think this is really really high quality piece of lunar imaging from Richard Bosman in the Netherlands. Many of our best planetary and lunar images are coming from the Netherlands at the moment. That was taken on February 24th, and you can see there, this is the Apennine Mountains. This is Archimedes here with many fine craters within it, and you can see the sinuous Hadley Rill of Apollo 15 fame that they landed near there and explored the Hadley Rill. I've noted some of the main lunar occultations, some of the best lunar occultations over the next couple of months. On April the 8th, we've got a star in Sagittarius, Pi Sagittarius, being occulted, and that's a 51% illuminated moon. And the best one in May is probably this one of Iota Capricornus, and that's a magnitude 4.3 star. An irrelevant illustration here, but this was obtained just the night before last by Guy Wells in Northolt, London, and that's a nicely, slightly colour exaggerated view of the moon with a long lens to show its mineralogy. I mentioned Guy Wells because he runs this, or he's part of a collaborative set of observatories in London and also in Dorset, which he calls the Northolt Branch Observatories, and they specialise in imaging near-Earth objects, and they've got some quite remarkable results on these near-Earth objects, and this is one of their results. This is an object which passed by very recently. It's a potentially hazardous asteroid, probably diameter of about 200 metres. It was discovered on February the 22nd from China, and it made a closest approach on March the 27th at only 3.5 million kilometres from the Earth. And this video was taken just a couple of days before closest approach. And it's moving at 48 arc minutes per hour. And the Northolt Branch Observatories, they actually take astrometry data and submit it to the Minor Planet Centre to enable the orbits of these potentially hazardous asteroids to be better determined. And let's see if that video, let's see if the video will play. Where is it? There it goes. Quite noisy images, but that's good enough. That will get you some excellent astrometry. Another close encounter of a different kind. This is an apparent close encounter. We've got an interesting conjunction in the morning sky very soon. This is a thing might be worth getting up for in the early morning before dawn to see Saturn and Mars come to the conjunction on April the 3rd at just about 1 degree distance, and they reach 14 degrees altitude before dawn. And this should be the view looking southeast at about 3 BST. So they are in the morning sky. They remain in the morning sky for the next couple of months. This is what the morning sky looks like in mid-May at 3:30 BST, and this is about the time of the beginning. This is nautical twilight. This is strong twilight. Saturn will get 15 degrees high, and it's being followed around by Pluto, although I doubt anybody will try and observe that in the twilight, and followed a bit further round to the east by Mars. And Saturn is heading towards opposition on June the 27th, and it's about magnitude plus 0.3, about magnitude 0, but it's going to be very low this year. It culminates at only 15 degrees, so we're not going to get high resolution images of Saturn this year. We'll be dependent on observers in the southern hemisphere for those. Mars similarly, unfortunately, although that has an opposition slightly after July the 27th, and that's got a large diameter, 24 seconds diameter is good for Mars, but unfortunately culminating at only 13 degrees, that's even worse. So again, it'll be interesting, but a bit sad that we'll have to rely on observations from the southern hemisphere for good resolution. But I've noted here also that we've got Vesta in the same part of the sky. That's the brightest minor planet that will be on display in the next couple of months, and that's up there just ahead of Saturn, and it's currently Mag 6. It gets brighter towards opposition, magnitude 5.5, and it has its opposition on the 20th of June. Here's a remarkable image of Mars. I think Damien Peach has taken this image. Obviously, it must be with a remote telescope from the southern hemisphere. Quite a small telescope, a 100mm high-quality refractor. Mars passing between the Lagoon Nebula and the Trifid Nebula in Sagittarius. 1.5 hours exposure. Here's a much larger scale Mars taken with the Chile scope, the 1 meter scope that Damien seems to have almost exclusive access to. And here you can see, he's actually got this wrong, it's actually north at the top here, so this is this would be an inverted view from the southern hemisphere or a direct view from the northern hemisphere. So there's the Syrtis Major, there's some clouds near the Syrtis Major over the Terminator. There's more clouds around the, that's called the North Polar Hood. So it's going to be an object that's not well seen from this country. Jupiter, similarly, is almost as bad. It's rather a sad arrangement of planets for us. Comes to opposition on May the 9th, a little bit higher, culminating at 22 degrees. Here it is. And this is where it will be in the sky in Libra on May the 9th. Here's one of Damien's images showing Io there, shadow of Io. You can see its interesting shape where the shadow is falling on the curved surface of Jupiter. Again, using the Chile scope taken quite recently, February the 19th. This is what I got. That's my best attempt in infrared on when was that taken? March the 9th. So you can't see a lot. All you can really see is that the south equatorial belt is more prominent than the north equatorial belt. The north equatorial belt has a few of these festoons on it. Christophe Pellier from Paris did somewhat better. There we see that these don't show up very well on the main screen at all. They're much better contrast ratios on the side screens, actually. And that's a colour image from Christophe Pellier as well. Here's a map produced by the WinJupos team, principally Chris Go and our colleagues, and the most important features being noted by John Rogers: continuing development of the large-scale pattern in the NEB, that's the NEB, interaction of the South Tropical Disturbance with the Great Red Spot. The South Tropical Disturbance is this area, this circulation here, and what is called the STB Ghost, which is here, transformation of the STB Ghost approaching oval BA. There's oval BA, and this is this very turbulent area here, the STB Ghost. And he's looking for more observations of those from really anywhere, but particularly places where Jupiter is higher in the sky. And here's an animation comparing different observations of the STB Ghost, and there is oval BA there. Of course, the most interest has derived from the Juno probe and the new announcement of the discovery of polygons, these polygonal arrangements of storms at the north and south poles of Jupiter, and this was announced in a paper in Nature on 8th of March, and you see a collection of authors, and there's our very own John Rogers there, joint author of the paper announcing the discovery of these polygonal arrangements of storms. Here John has combined an image from Perigove 1 with Perigove 4 to show this overall arrangement, and this is the South Polar region, and here you see the five storms, but they're not quite equally spaced round. In some of these other images, you see again the 5 storms and the South Pole, and these very evenly distributed eightfold symmetry of storms around the North Pole. And John Rogers writes that these patterns seem to be different in nature from the North Polar hexagon on Saturn. That's a kinked jet stream surrounding one big cyclone. But in contrast, each pole of Jupiter seems to have this polygonal cluster of cyclones. They're very stable. And they may be the first real-world examples we have observed of a thing that was known only from laboratory modelling in the past, a phenomenon termed vortex crystals. And here's some animations that John has created from combining together different Juno passes, and we can actually see the rotation of, go back to that one and try and get it to play. Yeah, there is some animation going on. These are the South Polar polygons, and I think this one is better. Yeah, that's interesting. It doesn't animate on that small screen, it animates on the big screen. Well, who would have thought it? Moving out in the solar system, I'll mention for completeness, Uranus is very close to Venus now, and this is the view in strong twilight at 8 p.m. BST, so you're unlikely to see Uranus. It'll be in strong twilight, and Neptune is also too close to the Sun. That is lost for a while now. We'll move on to the meteor showers in April and May. We've got a couple of good meteor showers, the Lyrids, April 18th to the 25th, and that's very favourable this year. It won't be interfered with by moonlight. It's a moderate shower, zenithal hourly rate, only 10, so to get good results, to see many of those, you'll need to be in a dark site. But a much bigger shower is the Eta Aquarids, but it's a southerly shower. It's not well seen from the UK. And that has a ZHR of 40, and that's active May the 20th, around April the 24th to May the 20th. So it's got a very broad distribution. Comets is a bit of a sad story at the moment. They're all around 12th magnitude. There's a number of comets which are all called pan-stars. 2016 M1. And that's in the early morning in Aquila, 11.5 magnitude. 2016 R2, and that's about the same or a little bit fainter. That's still visible in the evening sky in Perseus. And 2016 N6, about the same brightness. Another pan-stars, that's in Camelopardalis, and I've got some of the most recent images of these comets. This one comes from an observer called I think Spanish, Torre Miro, and there it's near a globular cluster, NGC 6760, and you can hardly see the comet. It's quite amazing that in that dense star field, having managed to identify that comet there. So this is, that's one, this is another one. This is 2016 R2, and this was imaged near the Pleiades by Denis Basinski in the north of Scotland. February the 9th, and you can see it's got a bit of a tail there, so that's an attractive image taken with a small telescope, a 61mm refractor. And here's an image of the other comet, the other pan-stars. This is from Michael Jaeger in Germany. This is taken from the German Comet Observer site, which has very good resources and up-to-date. I'm not saying the BAA site isn't up to date, but this is, has a lot of people contribute to this site, and there seem to be a lot of good, a lot of very active German comet observers who are frequently imaging these faint objects. So this is Michael Jaeger imaging pan-stars 2016 N6 just the other day in March the 20th. Variable star scene. Here is a variable star that you might be able to see in the next couple of months, the Sagittae in the small constellation of Sagitta, not to be confused with Sagittarius, Sagitta, the arrow, which is adjacent to Hercules. And this is data from the BAA variable star section showing how the amplitude has dropped in recent years. It's of a special type called a close binary super soft X-ray producer, and it has its own subclass. It is the prototype of its own subclass, the Sagittae subclass, and it's an eclipsing binary. So that's quite well placed at the moment, and an object that we'd like observations of. Another object which you can get at the moment, Andromeda, is still available in the northern sky shortly after sunset, Z Andromedae, and that's shown a downward trend in recent years, but it started brightening in early 2018, so it'd be interesting to follow that. And if you want to get more details of what the variable star section is up to, they've got their own Facebook page, and they also produce their own newsletter, which you can subscribe to, which is full of light curves. which we all love. Almost as you sound unconvinced. Almost as much as we like looking at spectra. Well, we've got some very active takers of spectra, and this also comes from the variable star circular. This is Myra, which has gone out into the twilight now. You won't see Myra again for a few months, but it had a period of maximum brightness. And February the 1st, it was third magnitude, and David Boyd's taken spectrum, and with his C11 and his LISA spectrograph, it shows titanium oxide absorption bands, which are apparently the sawtooth features. It shows emission bands. It shows the hydrogen emission, Balmer emission lines, and he's actually got two spectra in here. This blue line, only just above the axis, is actually a spectrum of the same star, of Myra, when it's at minimum. And in another chart, he has put these on a log scale so you can better see the minimum and how these compare. And he notes that they're similar, but the Balmer emission lines are not present when Myra is at the minimum. And also, there's more of a gradient of brightness going from the shorter wavelengths to the longer wavelengths. And so there's a change in colour. There's a change in colour index. Its colour index, when it was at minimum, was 1.96. It's now 1.19. So it's getting it's noticeably brighter at the longer wavelengths when it's faint compared to when it's bright. So it changes colour as well. So that's an interesting observation. I got this other spectrum from another contributor who I don't think we've mentioned at these meetings before, Kevin Gurney in Sheffield, and he's using a 10-inch and an Alpi 600 spectrograph, and he's been looking at an AM-type star. This is a Class A star with strong metallicity, and the metallicity is manifest in the spectrum by the increased amplitude of features between the Balmer lines. So these are the Balmer lines, and in the lower pattern he's rectified the spectrum and he's scaled the two stars for comparison, and you can see, so this is this one is the ordinary A-type star, and this is the metal-rich A-type star. And he also makes the comment on the website that he's amused how astrophysicists only seem to be able to count to 3, because any element with higher atomic number than 3 they consider metals. So it's anything that isn't hydrogen, helium and lithium. So this is a thing you won't see. This is the southern sky, and there's been a Nova Carina, and our esteemed colleague Nick Hewitt, who's here now, was actually happened to be in the right place at the right time. Nova was discovered by the Assassin survey, all-sky automated survey, on March the 20th, and he actually imaged it on March the 20th, but he didn't know he was imaging at the time. So do you think your first image actually predated the official discovery?
It was almost exactly the same.
Almost exactly the same. And he imaged it again on the 22nd. And luckily we've got a matching star in the database from the fantastic Gaia catalogue, which has accurate positions, even of magnitude 20 stars. and it corresponds to within 1 second of a known star. So we know that that star, magnitude 20 star, has brightened by 12.5 magnitudes to magnitude 7.5. So Nick did very well. He almost managed to see a nova in the moments of it coming on. But this man actually did see that. This man actually saw a supernova coming on. So I don't know if he's a BAA member or not, but I take my hat off to Victor Busso of Argentina, and there he is with his 40 centimetre Skywatcher Newtonian. This wasn't a recent observation, but it just came to my attention because it was just published. It was published in Nature in February, and what happened that was in 2016, he was testing his camera on this telescope. He was looking at a spiral galaxy, and he took a series of test images, and over 1.5 hours, he imaged the galaxy with a clear filter using 20-second exposures. And his initial series of 40 images obtained during 20 minutes showed no sign of the supernova. But after 45 minutes later, the supernova became visible, and he kept imaging for 25 minutes, and during that time the supernova doubled its flux. This, and it's commented in this Nature paper, of which he is given as a co-author, this deep detection limit and frequent sampling during the initial rise constitute an unprecedented set of observations for a supernova discovery. You'll be aware of the importance of supernovae in scaling the universe, and so getting an accurate understanding of the actual process of their explosion and their intrinsic physical properties is of the utmost importance in cosmology, and nobody has ever actually seen one coming on before in the first minutes of it actually doing so. And you can see that in these images. This is the image where it's not there, it's not in that circle, and you can see this is a smoothed out, this is a noise-free image because this is the stack of many images taken in that first period, and so they've got a upper limit on the magnitude for that, and there you can see in this subsequent, here it's coming on, and it's getting brighter there. And so this is from the paper in Nature. So a remarkable and very serendipitous observation by one of our colleagues in the amateur astronomy world in the Southern Hemisphere. And here's another Southern Hemisphere feature. We don't see this here, and this is a camera pointed down through the transparent Earth, or in fact it's taken from Lady Elliot Island, Australia, and here this is taken by our member Dean Ashton, and he took this in 2016, and there you can see the large Magellanic Cloud and small Magellanic Cloud, and you can see that's also not the Northern Hemisphere because there's no star in the middle there. There's no well-defined south polar star. It's a good time to look at globular clusters. We've got some lovely ones in Hercules in the evening sky now. Here's a nice image by David Swan from Tynemouth, and he's used a planetary camera, one of the ASI cameras, and a series of short exposures, 25 10-second exposures. So we're increasingly getting this, that people are imaging some of these bright deep sky objects using planetary cameras and stacking large numbers of relatively short exposures. And here's an image by another of our he's I don't know if Peter is a member of the BAA or not. He's active in the Baker Street Irregular Astronomers group, which meets in London, and he has a telescope in Spain, and uses that for remote observing. It's only a 150 millimeter telescope, but I thought this was the best image of the Owl Nebula in Ursa Major that I've ever seen. Normally with the Owl Nebula you just get the two eyes of the owl, really, and you get, if you're lucky, these two overlapping shells of gas of slightly different colours. But he's got this outer envelope which I've never seen before, and a lot of detail, a lot of modelling in that inner structure of the Owl Nebula. And he took that last year, in fact, but more recently, just the other day, in fact, he took Messier 94, and that's a great spiral galaxy of 40 billion stars, and that's again imaged from Spain using 152 millimeter refractor, a lot of exposure. A lot of exposure. So that's Peter Goodhue, and I'll just mention that to point out that we have the constellations Virgo and Coma in the evening sky in the next couple of months. Great hunting ground for galaxies from those edges of the universe down to right down to Earth. This is coming down to Earth with a bang. This is China's space station. Tiangong space station is going to return as a massive fireball. According to ESA, it's an 8-ton spacecraft, and it's going to hit between March the 30th and April the 2nd, somewhere in this band. So it's not going to hit us. This is the band where it's going to come down. This is a graph of population density, and this is a graph of impact probability, which surprises me that it looks like that, because it would appear to indicate that it has much sort of discontinuity here and much higher impact probability at these extreme ends of the latitude range, if I'm reading that graph right.
It's because it's basically sinusoidal, and if you work out the time over each area of latitude, you do get that for all kinds of inclined orbits. So
interesting.
The most likely re-entry is always at the highest latitude of the orbit.
So if it comes down at the southern end, it's not going to go through much population, but at the northern end, there's some major places in the way, like Nice or Washington D.C. there. I'm not suggesting it would be a good thing if it hit the White House, but maybe it would solve one or two problems. That would be a bit of a disaster. Here's another disaster of a different. This is more of a disaster of a PR type. Here's an astronomer's telegram. This is the astronomer's telegram used to be a real telegram. It's now emails sent out worldwide from professional astronomers announcing interesting observations and likely new discoveries for confirmation. And here, this a professional astronomer in South Africa, he's probably never going to work again. Peter Dunsby has reporting the detection of a very bright optical transient in the region between the Lagoon and the Trifid Nebula. Where have you heard that today already, between the Lagoon and the Trifid Nebula? Well, he observed it on the 8th of March, and it's at least first magnitude, and he's noted its coordinates. There is no obvious counterpart in the deep sky positions on the digital sky survey plates. Observations were obtained with an 80mm refractor, and it's the brightest star in this field. Further observations are strongly encouraged. So, well, I think we can help him out there. And of course, as our old friend Patrick would have said, he's made a completely independent discovery of the planet Mars. And
so the first couple of data points in cosmology.
He has got a good sense of humour anyway.
So here's the apology, and this is how the astronomer's telegram appears on the. If you view it on the web, the object has been identified as Mars. Our sincere apologies for the earlier report and inconvenience caused, but you obviously get adverts on the web as well, and obviously the astronomer's telegram, astronomers have to make money somehow, so I'm glad to see the Metropolitan Police has got involved with all the detectives that they will be able to recruit with this lovely fee they're offering of £30,000 a year. I'm sure they will be able to help professional astronomers to identify a lot more objects that us amateurs have known about since the beginning of recorded history. And that's all for tonight. Good evening all.